8:45?
They are.
Okay, so today what we're going to do is we're going to be introduced into a new way of solving equations that have variables on both sides. And I'm pretty sure none of you have done what I'm going to show you today. So, but what this does is it's an opportunity to kind of learn a very different but very potentially very powerful way of solving an equation. Yes.
Can you explain to me what's going on there? Believing 8:45?
No.
No, if you're singing, Nick, you're just gonna sit here in class until it's over, and then you'll be fine.
I'm sorry, I just didn't know what's going on.
Okay, there's a headmaster installation ceremony, and that's gonna happen in a little bit.
We're getting a new headmaster?
Okay, let's. Can everyone take a look up here? Okay, so what I'd like you to do right now on that piece of paper is see if you can't take a moment and solve the equation that's right underneath here before I show you another method of solving. So can you, if you don't have a piece of paper, please come up here and grab one. And I'm going to pause this for a moment just so that you guys get a chance to start this. So if you're listening to this, you can pause, and when you start, you will see the solution, the algebraic solution. Okay, so if you solve this algebraically, you should have gotten a 2. And what I want to do is I want to show you a different way of solving by graphing that will also get us 2. All right, will also give us that answer. So what we're going to do for this next method is we're going to treat each side of the equal sign as if it were a linear equation. So basically the idea is let's take the left side of the equal sign, and I'm going to set it as an equation y equals negative x plus 1. And I'm going to take the right side. Again, be patient for a moment because none of you have probably seen this before. Y equals 2x minus 5. Now what I want to do is I want to graph those two lines and watch where they meet. So does everyone see what I've done so far? What have I done, Jojo? Can you explain to me? Okay, yes.
You took the two sides of the equations and then added y in front of them?
Correct. And they're two linear equations as they stand, right? So let's go ahead and graph the first one. The y-intercept of the first equation is what?
1.
It's 1. And then what do I do to get my next point?
You go down 5. Down 1 over 1.
Down 1 over 1, right? Because it's negative 1. So this is the slope here is negative 1 over 1, which is down 1 over 1. So, okay, there you go. Okay? And I kind of like the way you guys draw those dots, but make sure at the end you do draw a line, all right? So there's your line. Mine should get a little straighter. No, it's not going to in this software. Okay, now let's do the next one. The next one says is a y-intercept of negative 5. So I draw my first dot on the y-axis at negative 5, right? And then what do I do?
Go up 2 over 1.
Up 2 over 1. And if you go up 2 over 1, you can see where it's going to cross, right?
Crosses like in the middle of near 2 1. 2 negative or 2 negative.
Okay, so the point that it crosses is 2, negative 1, right? What is the x value?
It's 2.
Does that sound familiar to you guys? Have we seen that before? So something very, very interesting is like, so you have, and in a moment I'm going to show you why this is going to be helpful when we get to very complicated equations. But the point is this: the x value, we can disregard the negative 1 y value. What we're looking for is what does x equal, and why is it that x equals 2? Well, the reason the x equals 2 is what is the equation asking for? The equation is saying what value of x makes these two sides equal, right? It's saying what value of x makes the left side equal to the right side? And does it make sense that that would be where the two lines come together? That's the 1x that's shared by both of them. So that's why this method works.
Can you show
Yes.
me again how do you get the? So I know how to get the x, okay, but then do you plug that in anywhere? You plug that in somewhere to get the.
Well, the answer is this. Okay, so what am I doing in this case? Anyone? What was my?
Making a point slope.
Yeah, I think my screen is freezing.
How do you get the y equals 2x minus?
Oh, okay.
Just put a line from it.
Okay.
What?
Yeah, it's confusing.
So all I did was, if you take the two equations, is I set this one equal to y. I said y equals this, and y equals that. I made them into a linear equation.
And you took which one you want to use?
And I'm just saying I took the left and I made it into a linear equation, and I took the right and made a linear equation. The question is, why is it? Okay, the point is, when I take them as linear equations and I look where they intersect, look at the x value, right? It's 2, which is what we would want the x value to be, right? So what I just did is I solved the equation in a very, very unique and different way. And the reason that works is because ultimately what we're looking for on left and the right side, I'm looking for an x value that works for both sides, that makes them equal. And that's the same as the solution of a linear equation. Let's try another one. Ready? So what we're going to do is, instead of solving this algebraically like we did at the beginning, I want you to solve this using lines. So let's go to the next one. The next page. Next page is for you. And what we're going to do is we're going to graph two lines, right? So I'm going to start. Let me go ahead and start you off. What's the first line I'm going to graph?
2x.
Okay, y equals 2x is one line I have to graph. And if you wish to, you could say 2x plus 0, because that's the y-intercept. What's the other line, Nick, that I need to graph?
I say -3.
Okay, no.
Y equals 1 half.
Right, y equals 1/2 x minus 3. Okay, so what we're going to do to solve this is we're just going to see where they cross and take the x value of that place that they cross. So go ahead and take a moment. If you're listening to this, pause it and go ahead and graph those two lines. So let me turn on the microphone so that people can see me graph. So again, okay, so we graph the y equals 2x plus 0. 0 is the y-intercept, and then we go up 2 over 1. And the next equation, again, is we start at -3 as our y-intercept. And what do we do again? We go up 1, and over 2 to the right? Or down 1 and over 2, so you guys can see where does it intersect?
Right here. Just check.
All right.
Like that.
Right. You guys take care.
-2, -4.
Okay, you're going to hear this video. I'm going to post it up there so you guys can see it tonight, all right?
-2, -4.
So the answer, right. So the point of intersection is -2, -4. And what is the value that I'm looking for, though? X equals what? What is the x value of that point?
-2.
-2. That's the solution. All right? So you just solve that equation. If you don't believe me, go ahead and put -2 in there. If you, let's go ahead and put -2 into the top equation. I'm going to write 1/2 times -2 minus 3 equals 2 times -2. Well, what is 1/2 of -2?
1.
-1, right? And then you got -1 minus 3 is,
-4.
and then over the left side you got -4, 2 times -2, right? So it works. Has anyone ever solved an equation this way? I'm predicting not, right? So Olivia, if you could close that computer, that would be awesome. Okay.
I saw a shift this morning.
So what I'd like you to do right now is see if all on your own
Oh.
you can solve number 2.
Whoa.
That was straight edge.
Whoa.
And here's a straight edge for those people that are neat about this. Anyone else?
Can't find the right button.
Anyone else right here? Okay, so I'm going to pause this for a moment and
Whiteboard.
invite everyone to do it themselves.
We don't play no game.
Turn on the microphone again. All right, so I don't think mine came out as nicely as yours did, but you guys said you felt that it's like 1/2, 1/2. Was that the consensus?
Kind of what.
Okay, even though mine isn't so as good as yours, 1/2, 1/2, and then you guys, someone checked x equals 1/2,
Yeah.
and it worked, right? So
Everybody saw check for one.
it's magic, though, isn't it?
I agree.
So there's no way to check for y because y is a value that we put in ourselves. So you could plug it in to the 2 equations, couldn't you? So for instance, if you have x is 1/2, right, and y is 1/2, you would go 1/2 equals 9 times 1/2 minus 4. What's 9 times 1/2? Is 4.5, right? So you got 1/2 equals 4.5 minus 4, which is just a half, right? So you guys are perfect. So even if you had to find y, but the key thing is that we have a new way to find x. When would this be useful? When you have slopes like 2/3 and -5/7, things like that. If you have equations that have those crazy fractions, you would be able to solve them by graphing. Now, if we have a calculator, how many of you guys have your TI-84 calculator?
I have it. It's at my house.
What?
I have it.
All right. So, well, you might be able. Okay. So, I'd like you to get it because you're going to be seeing it next year. But what I want to do is I want to show you how we solve these inequalities using the same method. All right. So here's 2 equations that we can rewrite as inequalities. Now, I'm going to have you take. I'm going to not have you use your computers for a second, so just tilt them toward you. And Karem, if you could put your phone somewhere where not tempted to go and, there you go. It wasn't a phone. It was a nice calculator. Okay. So let's go ahead and set this up. First of all, does everyone remember what these straight lines meant? Absolute value, which means that any value that comes out of them turns into a positive, right? Positive. So if it's negative inside, it becomes positive. If it's positive inside, it becomes positive, right? Quick review here. What is that equal to? 4. What is this equal to?
4.
Okay. How about this one here? If I have x plus 2 is equal to 4, does anyone remember how I solve this? How I rewrite this? There's 2 answers to these equations now, by the way. Right? Does anyone remember the steps that I use to solve it? I separate this into 2 equations. Right? Now remember, the question says x plus 2. What is inside? Right? What are the 2 things that x plus 2 can equal? X plus 2 could equal 4, or if x plus 2 equaled -4, everything works, right? So if what's inside equals 4, or if what's inside equals -4, the equation works. So this is how we separate it into 2 equations. Okay? So I just wanted to recollect that for you. Let's go ahead and graph this. All right? So, well, actually, I'm not going to graph this yet. Let's go to, let me erase that, and let's go ahead and do a problem, right? So what I'm going to do is that we're going to use the same method that we used before for graphing. And But now what I'm going to do is I'm going to show you what this inequality looks like. So this inequality can be written two ways. It can be we can say that x plus 1 is equal to a positive value of 2x minus 4, right? Or it could be equal to a negative value of 2x minus 4. So whatever's on the inside, x plus 1, can be either equal to a positive value of the 2x minus 4 on the inside or a negative value. Or if you will, it's just going to be the same thing, right? We take it out of the absolute value signs, we make it either positive or negative. So this should look at least similar to what we were just doing, right? So let's go ahead and get rid of all those parentheses. So I've got x plus 1 equals 2x minus 4, right? But I also have x plus 1 equals negative 2x what? Plus 4. So now, how many equations can I draw? All right, yeah, I'm going to draw two sets of lines because how many values for x do you think I might get here? So let's solve the first set, all right? Nick, is that you put on that computer helping you learn? Okay, just in case. All right, so let's graph the first one, guys, all right? This one and this one. X plus 1. So what's the y-intercept? 1. Slope? Up 1 over 1, right? You guys still with me? So let's solve, basically I want to solve this part first, and then I'll solve this part second, okay? Are we good? So anyway, so I'm doing this equation first, and I created this line. Right there. And let's go to the other equation, the 2x minus 4. How do I graph that one, Nick?
Go to minus 4.
Yeah, draw a dot.
And then go up to right 1.
Up 2 over, right? Up 2 over 1, up 2 over 1. Some of you guys, I see some of you guys do this, and then you just get to the point where there's the graph, up 2 over 1. So that looks like the intersection point, doesn't it? And what is that point? Most importantly, what's the x value of that point? Anyone? 5, right? It's the point is 5, 6, but we're interested in the value 5, right? So we have x equals 5 over here. So let's graph the next one. Now the first line is fine, right? Does everyone see what I'm saying? The first line is the same, x plus 1. But the second line's not the same. It's going to be, we're going to have a y-intercept of positive 4. All right, and then how's the slope going to work? Kurt, what do you think? Now we're graphing this one. Down 2 over 1. Oops, right there, right?
Yeah.
So, and what's the x value of that point?
1.
It's 1. So the trick is, do you think that works in the those equations on the top? Let's try 5 first. All right, let's try 5 for these equations. So I go absolute value of 5 plus 1 is the absolute value of 6, right? And if I put 5 in for x here, I get 2 times 5 minus 4 is what? 6. Not 16, 6, right? 10 minus 4. Okay, so does the value 5 work for x? Does it? You guys listen. This is brand new stuff. Don't think that it's just going to be, oh, I'll just kind of like wing it. This is one of those days that if you're not paying attention, you're going to take a quiz in the next week and you're going to have no idea what's going on. So please just wake up. Oh, that's a great idea. So let's wake up and be thinking about what's going on. I know it's not easy. It's a weird day. It probably took you an extra half hour to get dressed. I don't know, but what I'm doing right now is let's recount what's going on. First off, is that I created 2 equations. All right. I created 2 equations. This equation here, right? And this equation here. How did I create them? One of them's positive, one of them's negative. I said x plus 1 equals the positive side, positive on the right, and it also equals the negative on the right. Good? Okay. And so we're ultimately talking about what's inside. And then once I had those 2 equations, I am solving by graphing, linear graphing. So the first one I solved, and I got 5 for x. I just checked the value 5, and I noticed that it works. What's my other value let me just take these things out. What's my other value for x, Shane? See here? New. Okay, what's my other value for x, Ines? 1. Let's go ahead and plug in the value 1 and see what happens, right? So let's go back up to here, and I'm going to plug in 1. I go 1 plus 1 is going to be absolute value of 1 plus 1 is the absolute value of what, Kai? 1 plus 1. Come on, you can do it, dude. Okay, does anyone else can help him? 1 plus 1
is equal.
It's 2. Yeah, good. All right. Hey, welcome to the United States. Anyway, now I'm going to plug in 1 on the right-hand side. All right, Kai, see if you can learn and eat noodles, all right? So what's plug in 1 at where the 2x minus 4 is?
Just plug in 1, yeah.
Okay, plug in 1 for x, right? It's negative 2. Does the absolute value of 2 equal the absolute value of negative 2? Yes. So what does that mean? That means that my 2 solutions, right, to that absolute value thing are correct. Now, Nick, I'm scared you're going to get your hand stuck in your computer. You're going to be all right?
Yeah.
Okay. Whew. Yeah, I think it looked like it was closing down on you. Let's close it just a little bit further, right?
Yeah.
Why don't you close it all the way? The computer.
Okay.
Thank you very much. I appreciate that. Okay. Now let's go to one for you guys to do. All right. So this is the big deal. Is the ones that I just showed you. All right. Let's go to the next page. Are ones for you to do. Well, what I'll do is I'll kind of help you on the first one. I didn't mean to spend 5 hours on that first one because really isn't that hard. Okay, first off, can someone that was I would say Ryan, I'm going to let you do. Can you tell me the 2 equations they're going to come from this inequality?
2x plus 2 and
2x plus 2 equals
equals
x minus 2, correct? All right, and then the next one's going to be 2x plus 2 equals
x plus
negative x. All right, the opposite, right? It's going to be negative x minus 2, which is going to be what? 2x plus 2 equals
negative x
plus 2. So those are my 2 equations, all right? So the difference between what we did at the beginning of the day and now is that we have to do it twice, all right? So let's graph this one first and this one second, right? So graph them now, everyone. Yeah. I'll graph it slowly. I'm hoping you guys can graph it a little faster than I am going to do it. Anybody find it? Okay, I'm thinking it's -4. Right? Is that what you got? So it's -4, -6, but we don't need to use the
I
-6.
got -6, -8.
-6, -8. Yeah.
Yep.
Yeah, it is -4 though. I can plug it in already and it looks like it works. If you put a -4 into the equation, it's yeah, that's all. And then for the next one, you notice that the 2x plus 2, we already graphed it.
Let me just like put this in.
So let's graph the next one. So the next one is going to be what's the other equation going to be, Olivia? That I have to graph. So -x plus 2, right? So I'm going to go up to 2. Oh, looks like that must be the intersection point right there, isn't it? So 2, and then I go down 1 over 1, down 1 over 1, and you can see right there the intersection point is. What's that? What's the intersection point? 2, 0. No, 0, 2, right? So if the intersection point is 0, 2, what's the value for x? 0. So the two answers are -4 and 0. All right? Nick,
Yeah,
sit right up here. I need you to be up here.
I'm gonna be worse up there. It's gonna be so much worse.
No, at least I can slap you around when you're like, put your head down when you're sleeping like that. Nick. Okay. But I'm not convinced that you know how to do this until you do this next one. Okay, so is everyone, okay, let's briefly summarize. What's the first thing I did, John?
Find two equations. You made the lines.
I made the two equations. Okay, well, before I did that, I made the two equations. Nick is actually right on that one, right? I made the two equations, the 2x. I made the 2x plus 2 and the 2x plus 2 equals x minus 2, and then 2x plus 2 equals minus x plus 2, right? So it equals the plus value and the minus value. No different than how we solved these inequalities in the past, right? So even though it's like two inequalities on both sides and it looks really weird, we're still solving it the same way. So now we've got two equations equal to each other, and then we graph them. And what are we looking for? We're looking for the x value where they intersect, all right? So understandably, this is a little bit different than the way we solve algebraically, but you need, so what you're going to be tested on eventually is being able to get the answer by graphing. So if you can do number 4, if you can go on number 4 and do that one on the next page, you are in a great place to do the homework. So see if you can't, working with somebody or whatever, do this next one, and I'm going to pause this right now, and I will put the work together for those of you listening to this. I'm going to pause you right now, and I need you to do number 4 on your own.
Yeah, I don't get how you get like the second, like the one to like the right. Like I got the x minus 6, the negative x plus 4.
Okay, so, all right, to write the two equations, you take what's inside here. What's inside here can equal a positive value of what's inside here, or it can be equal to a negative value of what's inside here. So x minus 6 could equal the positive value, which is just minus x plus 4, or the opposite, which over here is positive x minus 4. All right? So the idea is it's like this. It's like saying that absolute value of 4 is equal to the absolute value of negative 4 or the absolute value of just 4, right? Right? So what's inside can either be, sorry about that color, what's inside can either be negative or positive. And that's what we're trying, that's the statement we make when we solve it. So anyway, going back to the original equation, just to make sure we know what's going on, so you can do this in your homework.
But why is the x minus 6 not changed at all?
It doesn't need to. We just got to make sure that the other side changes. Now you might ask, well, what if the x minus 6 was on the other side and we wrote it this way? You know, good question might be, what would happen if I said minus absolute value of, let me change the color, absolute value of minus x plus 4 equals absolute value of x minus 6. What did I do here? I just switched them. Then I would write it how? I'd write negative x plus 4 equals x minus 6. And what else? X plus 4 equals negative x plus 6. Guess what? You get the exact same answers. All right? But the point is this, is what we need is just a reference point. If we start on the left side, we say whatever's on the left could either be positive 4 or whatever on the left could, could either be positive 5 or whatever's on the left could be negative 5, right? So as long as we keep that pattern, we're fine. Yes? Yeah. Okay, so what's kind of nice is that it's hard to screw up, you know? So quickly reviewing on this one, all right, we took the equation and we set it up as x minus 6. What's inside the left one equals what's inside the right one, or what's inside the left one can be equal to the opposite of what's inside the right one. We write the two equations, we graph them, we get the x values of the intersection, and in this case, one doesn't give us a solution, but the other one does.
The 4, 0 does not matter.
And the 4, 0, it does matter. No, it doesn't matter. You're right. It's we're only looking for intersections with the blue line, right? Because the first one, remember that the first one was the blue line and the red line, right? And so we need the intersection of the blue line and the red line. That gives us the 5. The next one says the blue line and the green line, right? We're solving the blue line and the green line, and they don't intersect. So that's the no solution part, okay? So if you put the 5 in here, let me just do that one last thing. And then I'm pretty much done. You can start your work or run for help. But anyway, if I put a 5 in here, I get absolute value of 5 minus 6 equals the absolute value of negative 5 plus 4. Can you guys check and see if that works? What's 5 minus 6? Absolute value of negative 1 equals absolute value of negative 1. Is that correct?
Yeah.
Yeah, 1 equals 1. Okay, so a unique way of solving and getting the answers, right? So why don't you guys, I'm going to let you guys take a couple minute break. We're going to be done at 1:30, but what I want you to do is to open up your assignment in a moment and try one problem. Make sure you get it. All right? But I don't have them up there yet. So that's it for the video. Good luck. See you next class.